For our first analogy, visualize a rope stretched tightly between two springs. Electrical engineers have known for a long time that pulses traveling on wires behave a lot like waves traveling on springs or ropes. So, if you can visualize a rope stretched between two springs as illustrated in this picture, there's really no need for you to worry about the electrons or the magnetic waves or the molecular structure and physics of a cable. We'll leave those secrets and those details to the engineers, and we'll just talk about the concepts here. If you grasped the rope as shown in this illustration, you could feel any vibrations that happen to be passing through it, or you could generate some vibrations or pulses of your own by tugging on it, pulling to the left or to the right. If somebody else placed their hand at the other end of the rope, they could feel the motion that you impart to it when you tug it to the left or to the right. The two of you could agree on the way you would communicate the most basic bits of information. For example, you might agree that if you tug the rope to the right, you are sending a message that says 1. Whereas if you tug the rope to the left, you're sending a message that says 0. In both cases, you could just relax the rope and let it return to its center point between bits. Observe that in this diagram there are only two of you sharing the rope. We call this a point-to-point connection, or a point-to-point network. In a point-to-point network, the recipient of every message is obvious. When one party on a point-to-point network transmits a message, it's obvious that that message must be destined for the other party, so there's no need for the message to contain any address information. But now, suppose that a third person joins the network by placing his hand on the rope as illustrated here. Now, when you send a message, it is no longer obvious which of the other two parties is the intended recipient.
AskMisterWizard.com